For the following line, name the slope and y-intercept. Then write the equation of the line in slope-intercept form. Okay, so we have a line, and we're not given any clues about the line other than the graph of it. Now, the good news is we can very easily construct the equation of a line. We could use a couple of different things. We could say using the slope-intercept form, which is y equals mx plus b, as long as we know what the value of the slope is and we know what the y-intercept is, we can take those two pieces of information and plug right into the slope-intercept form. Now, given that we know the graph of the line, we could probably find this information readily easily. So for instance, in order to get the y-intercept, all we need to know is where does the graph pass through the x-axis? Or, my fault, the y-axis, that is. So this point right here is where the line is passing through the y-axis, which is at the point 0, -3. And usually it's just the -3 that's important because for any y-intercept, the x-coordinate will always be 0. So that tells me the value of b, which is -3. Now the slope, all we need to do to find the slope is just go from this point here, or any point on the line, it doesn't really matter, and find the next place where the line crosses through a very visible point. Probably going to be integer based, but say for instance right here, that's a good one, or even right here is a fine one, or even back here. So there's a few of them that we can work with. We just need to determine how far vertically and how far horizontally we have to travel to get from one point to the next. So for instance, from this point here, if I go up 1 unit and I go over 1, 2, 3 units, so 3 this way and 1 this way, then that tells me my rise, which is the vertical change, and my run, which is the horizontal change. And the slope of a line, which we call m, is the comparison of the value of the rise to the value of the run. So in this particular case, the rise over the run is 1/3. And since we already learned that b was -3, we can take those two values and plug into the slope-intercept form and say the equation of this line is y equals 1/3 times x minus 3. Now that's not the only way to find the equation of the line. There's another prominent method as well, which is using a different form of the line, which is known as the point-slope form. The point-slope form is a little bit more versatile because it doesn't require the knowledge of the y-intercept. Sometimes the y-intercept isn't readily available information, and so the point-slope form comes in handy in those cases. So the point-slope form looks like y minus y1 equals the quantity, or m times the quantity x minus x1, where m is of course the slope of the line, and then x1, y1 is any point that exists on the line. So if we were to identify a point that was on the line, so this one right here will do, I can say the coordinates here are 6 and -1. That looks great. And I already know that the slope is 1/3. I'll just use that information. What I can do is I can take the coordinates of this point, so y minus y1, so y minus -1, equals the slope 1/3 times x minus 6. Now, of course, the -1 here will cancel and make this positive. So I have right now y plus 1 equals, and I will distribute the 1/3 into this set of parentheses. So 1/3 x minus 6/3. And then if I subtract 1 from both sides, it will cancel out on this side, leaving me with y equals 1/3 x. And then I have 6/3, which is actually just -2. So -2 minus 1 is -3. So there's lots of different ways of getting the equation of a line, but most of them revolve around finding the slope of the line and at least one point that exists on the line.